There's a town on the Mississippi River in Missouri called Herculaneum. It's named after the Roman city that was buried alive by Mount Vesuvius, the one right next to Pompeii, which is a strange name to pick for a town until you learn what that town did for a living. Because for 120 years, Herculaneum, Missouri ran its own kind of volcano. Furnaces 2 stories tall, glowing white hot, turning gray Missouri rock into rivers of molten metal, day and night, right on the riverbank. It was, for most of that time, the largest lead smelter in the United States. At the end of the last episode, we had a damp gray powder, lead concentrate, straight from the mines of the viburnum trend, and I told you it wasn't metal yet. To turn that powder into the shiny gray lead you'd actually recognize, you have to do 2 things to it. You have to cook it, and then you have to clean it. And here's the thing almost everyone gets wrong. Those are not the same job. They even have different names. Cooking it is called smelting. Cleaning it is called refining. And if you don't keep them straight, none of the rest makes sense. So let's make it simple. Smelting is extraction. You use heat and carbon to rip the metal out of the rock, to break the chemical bond that's trapping it, and pour out crude, dirty lead. Refining is the cleanup. You take that crude lead and strip out everything still hiding in it until what's left is pure. Smelting gets the metal out. Refining gets the metal clean. Think of it like an orange. Smelting is squeezing out the juice. Refining is straining out the pulp and the seeds. Let's start with the cooking. Remember what that concentrate actually is? Galena. Lead locked onto sulfur in a compound called lead sulfide. Step 1 is to get rid of the sulfur, so they roast it. The concentrate is spread out and burned in open air, and the sulfur reacts with oxygen and floats away as a gas, sulfur dioxide, that sharp, throat-catching smell of a struck match. Hold that thought about the gas, by the way. It matters later. What's left behind once the sulfur is burned off is a crumbly gray solid, lead oxide. The lead has traded its sulfur for oxygen, and that's a problem we can actually solve because now we just have to get the oxygen off. That's the job of the blast furnace. The roasted material, mixed with coke, which is almost pure carbon, and limestone is dumped into a towering furnace and blasted with hot air. The carbon, starved of oxygen, becomes a hungry gas called carbon monoxide, and that gas tears the oxygen right off the lead. The rock melts. The waste floats up as a glassy slag, and the lead, heavy, molten, finally free, sinks to the very bottom and pools there, and is tapped off like water from a barrel. That is smelting. That is the whole job of it. You started with lead glued to sulfur inside a rock, and you ended with a puddle of actual liquid metal. But, and this is the part people skip, that metal is filthy. What pours out of the blast furnace is called base bullion, or work lead, and it's only about 95 to 99% lead. That last 1 to 5% is a stew of other metals that were hiding in the ore the whole time and came along for the ride. Copper, arsenic, antimony, tin, bismuth, zinc, and remarkably, silver, and even a little gold. So now the second job begins, the refining, the cleanup. And it's not one step, it's a whole sequence, and each step is designed to pull out one specific thing. First, copper. As the molten lead cools just a little, the copper can't stay dissolved, so it rises to the top as a scummy crust. They call it dross, and a worker skims it off the surface with a giant spoon, like fat off a soup. Next, the metals that make lead hard: arsenic, antimony, and tin. They stir in molten caustic salts, which grab those 3, pull them out, and float them off as more scum to be skimmed. Metallurgists actually call this step softening, because those are the very elements that make lead stiff, and taking them out makes it soft again. And now comes the strange one, the good one. Remember I said there was silver hiding in there? Here's how they get it out. They pour zinc into the molten lead. And it turns out that silver is about 3,000 times more comfortable dissolved in zinc than in lead. So the silver, and any gold, abandons the lead entirely and rushes into the zinc, which floats up on top as a separate silvery crust. You skim that crust off, and you've just pulled precious metal out of a vat of lead. This is the Parkes process, worked out by an Englishman named Alexander Parkes around 1850. And it means that the Missouri lead coming out of Herculaneum was quietly, for over a century, also producing silver. But now you've got a new problem. You just poured a bunch of zinc into your lead. So the next step is to take the zinc back out. Zinc, conveniently, boils away at a lower temperature than lead, so they can essentially simmer it off under vacuum and collect it. There's a nice little irony there. You add the zinc to catch the silver, and then you have to remove the zinc you added. Almost done. There's one last stubborn impurity, bismuth, and it's the hardest to remove, so it gets its own dedicated process. They stir in calcium and magnesium, which grab the bismuth and freeze it into a solid clump that floats to the top and gets skimmed away. That one's called the Betterton-Kroll process. A final cleanup, and at last you have it. Refined lead, 99.9% pure or better. From a gray rock, through fire and skimming and a half dozen chemical tricks, to a gleaming bar of pure metal. Now, there is a shortcut. Instead of that whole fire refining sequence, you can purify lead with electricity. Cast the crude lead into slabs, hang them in an acid bath, run current through it, and watch pure lead migrate over and plate out clean, while the silver and gold and bismuth drop to the bottom as a valuable sludge. It's called the Betts process, and it's beautiful, but it's expensive, which is why most smelters, including the classic American ones, stuck with fire. And Herculaneum did all of it, the roasting, the blast furnaces, the refining, under one operation. The St. Joseph Lead Company chose that spot on the river back in 1887 and lit the furnaces in 1892. From the very beginning, it had blast furnaces and a refinery side by side, smelting and refining, the two jobs in one place. At its peak, it turned out around 225,000 tons of refined lead a year, and it ran for 120 years. But go back to that very first step, the roasting. Remember the gas, the sulfur dioxide, and along with it, fine dust carrying lead itself, drifting off those furnaces and out over the town, year after year after year. For most of the 20th century, that was simply the price of making metal. But the ground and Herculaneum was soaking it up. The children were breathing it, and eventually, the country was going to look at this 120-year-old way of making lead, the fire, the smoke, the poison drifting over a river town, and decide it was finished. That's the next story. The day America made its very last batch of lead from rock, and what we started doing instead.